Hello, my name is ch1. This is the summary of the chapter 1 and chapter 2 about PDF file 2, radical IF biosensor. Okay, as you can see, there's so many titles. One, resistive thick and thin film gas sensors built with nanomaterials and related research. Introduction. Thick film sensors made from nanocrystal SNO2 showed a 30% to 37% increasing sensitivity compared to those made from microcrystalline materials, with a significant reduction in operating temperature. Add-up and in-depth SNO2 sensors demonstrated selectivity for ch1 volatile organic respectively, while pure SNO2 sensors were sensitive to HR. And there are two features as follows. Thin film sensors and MEMS micro heaters and electronic control. So 1.2 factors affecting the gas sensing process. Factors affecting the gas sensing process. As you can see in the image, this is a model of tensional barrier for electronic conduction in a grain boundary. Schematic models of grain size effect. 1.3 experimental produce and results. So there's some equation. That means how it works. And as you can see, the image on the right is a architecture of the MEMS hot plate. So as you can see, there's something regarding ch2O2. So we can draw the conclusion about that. And that is experimental produce and results. This is a diagram of the electronic control system. And the right image is the double Mender resistors and item fig 1.8a with sensitive film, and diagram of the double Mender. Diagram of the double Mender resistors in heating mode. And this is the experimental produce and results. And the third process, a diagram of the double Mender resistors. And this is a response of a gas sensor built with AI2. And this is some image about the tendency of time and water temperature resistance change with time of a gas sensor built with 1. And this is response of sensor built with 1.4 experimental produce and results. So this is the response to the reference standard pure SNO2 diffraction pattern. And this is the diffraction patterns corresponding to spacemen as thin thesis by adopting and something about that correspond to the reference, then the pure signal-to diffraction pattern. And the SP spectrum and SEM film micrography at on surface and beyond profile. The SC spectrum and SME film micrographies see on surface and beyond profile. The DC spectrum and SEM film micrographies on surface and F on profile. So this resistance versus operation temperature for HR sensor. And the middle image is sensitivity change with for different CO2 CO penetration in this sensitivity. 1.5 conclusion. The conclusion about is it has 2-point thick film gas sensors and thin film gas sensors. This is the same as the introduction. So we can draw some conclusion, some details about the introduction I said before. So 2 gas phase synthesis nanostructure oxide-based gas sensors. Production. There are 4 points: sensing mechanism, nanostructured oxides, challenges with nanoparticles, physical chemical parameters. Point 2, measurement setup, sensor array, and preparation of films and for electrical and gas sensoring characterization. So this is the some images about a block diagram of the complete gas sensoring measurement setup. Measurement cell is between both of the market, so that all electrical measurements can be done in one cell with the permission of AI publishing. And the image to the right scan codes of the micro hot plate design for gas sensoring measurements. And point 3, studies on SNOX films made from size selected nano particles. So there are 2 diagrams about some changes about time and length and sensor response and sensitivities. And there are some images about the other features, temperature and gas sensitivity. And 2.4, studies on xeno films made from polydispersed nanoparticles. And there's some images about that. Time, gas concentration, and temperature. So it's the change of the response values with temperature under 1000 ppm of different reduced gases. And that is current voltage response of the xeno sensor. So this is the physical model showing the effect of the oxygen as portion and reduction on this. So next part, conclusions. So we can draw the conclusion. So this is a more specific details about the introduction, the XID sensors, and the zinc oxide sensors, and the depletion of the conduction electrons at the intergranular how this uh uh I IV behavior in oxiding atmospheres and under reducing gases the electron transport results in high sensor response and lighter IV coverage. Okay, that's all. Thank you.